Hi everyone. My presentation is on migrating to Kotlin state and shared flows, and I'm going to present to you on how state and shared flows work. I'll present to you on how it compares to a broadcast channel and how you can migrate from a broadcast channel to a shared flow. And lastly, like we'll talk about how do you handle like when you have a buffer overflow and start. So the first important basic concept to understand is the difference between a cold flow and a hot flow. So a cold flow is a stream, is a flow that triggers the same code every time you collect from it. And let me share with you an example of it. So here's an example of a flow that has three values, 1, 2, 3. It emits them, and then it gives it downstream to the mapper, which increments it. Simple flow. And every time that you collect from it, the flow emission will start from the top. It will emit the three items, and you'll get a result. So every time that there's a subscriber that collects from the flow, it basically starts from the top and then it goes through the mapper in the stream, and then you get the same result. So every time you collect from it, the flow is going to get triggered every time from the beginning, and that's the property of a cold flow. Whereas on the other hand, the hot flow is different. It's not dependent on its subscribers. And in Kotlin coroutines library, there are two ways to model a hot flow using state and shared constructs. So for this presentation, let's start by looking at what is a state flow and how do you use it in the context of Android. So and in Android, you may be using a MVVM architecture, and you could have a view model that can, and then the view model could have a stream of UI states that it communicates to the view with, and what the UI should, um, and you can model this UI state in a common practice is to use a steel class, which has, a state loading success. You got some data, you give it to the UI, or some type of an error, and you could, have an error message there. So you could model basically you could have a view model that that exposes a stream of those UI states. So how do you set that up in your view model? So over here is an example of, I have something called a mutable state flow. I'm constructing that, and a mutable state flow, when it requires in the constructor to give it a default state, and it could be loading, for example, and or it could be null. So how do you now emit to this immutable state flow? You could call it an emit method, which is suspending. You could, pass it whatever value you want. Another way to emit something from the state flow, to give something to state flow, is by updating its value field, and this is not suspended. For you to emit to the state flow, the last thing that was emitted, it gets stored internally in the cache, and as with regular cold flows, you could collect from it and apply any operator you want, like map, flat map. And every time you collect from it, you have multiple subscribers that might be collecting this value that was emitted to the state flow. So you get the latest value even if you have another subscriber that came in. So I may have back emissions, and it will conflate those emissions and take in whatever was the latest thing that you sent to it, which is in this case is an error, and that will be sent out to that will be the state that the subscribers will receive. So it has this property of conflation, this state flow. So and that's in the subscriber will receive an error. So the way to model this stream is to use live data, and live data and state flow have differences. So whereas in the state flow, as you saw, you have to, when you declare and set it up, you have to give it a default value that it will have, whereas it's not the case with live data. There's also a difference in unsubscribing and cleaning it up. And recently, a extension called Repeat on Lifecycle was added that you could use, and it will provide the same behavior where it will, unsubscribe from the state flow based on lifecycle changes. So those are differences between live data and state flow. So what we looked at so far was the basics, mechanics of setting up a state flow, emitting things to it and collecting from it. So the other version of basically the other thing that you could use, which has a lot more features, is a shared flow. And a shared flow has the ability to replay things, to specify a bigger buffer size. And let's look at how that works. So similar to state flow, you could also use a shared flow to broadcast events out to multiple consumers. And one of the things that it has is that you could replay any number of you could specify how many events to replay to consumers that were sent out previously. So it has that feature, and it also has the ability to buffer. You could cache. So you could have a producer that's basically producing a lot of events and the consumers are not really reading it as fast. So you could specify a buffer in that case. And so those are the big features of a shared flow. And it has like an Rx of a replay subject, etc. So how do you set up a shared flow? Over here, shared flow in there, and the difference is that this shared flow is going to emit, this is going to be a flow of sample. In the constructor, I don't have to specify a default value in there. Unlike I'll show you there are ways to find replay count or overflow strategy, those types of configurations. I'll show you how to set that up. I'm launching a code and scope, and I'm listening to this flow. Right now, it hasn't emitted anything. I have a subscriber to it. And then in another code do is that I'm going to emit to this shared flow some string. And when I emit to it, my receiver, all my subscribers will receive this string. In this example, event 1. So what if you had an example where, for some reason you have a delay, and then you're collecting from the flow. So when this code executes, it doesn't have a subscriber immediately, it's after a delay. So when this coroutine gets launched, when you emit this event, there is no subscriber. And the value, and by the time that the delay is over, it goes after the delay, collects from the flow, it won't receive any value because it didn't replay count. So that replay count on a mutable shared flow is 0 by default in the constructor. So the replay is 0. In order to replay what was already sent, you could set up a count of 1, 2, or 3, or whatever you want. So in this case, then it will replay the most recently sent value, which was the string. So you could, in your code, in your producer code, or you could determine what is the subscriber count posed to you as a property in the shared flow as it's internally, its type is a state flow. And you could get how many basically subscribers you have by doing .value and in your code. So right now there are 1 subscribers in this example. So it's another thing is that why am I launching multiple coroutines, 1 for subscriber, 1 for producer? Because if I didn't, flow.collect will suspend. So it's good in this example. And the suspending method, any code underneath it won't get executed. So it's good to separate out, your producer, consumer, and separate coroutines. So another important property to understand is that a shared flow doesn't complete normally. So in this example, like you'll never have, like if you were to put an on completion block and lock something out in there, you'll see that it will never really get called because the flow will never complete normally. And in a cold flow, this is an example of a cold flow of a regular flow, which emits just 3 items. And after they have been emitted, on completion gets called. But over here, you'll never see and hear on complete get called. So the other thing is that, how do you cancel, your subscriptions by canceling the job. So I have a subscriber that's listening on a coroutine here and collecting from the flow, and I take the job and I call cancel on it. And when I do that, this flow, the on completion, gets called because completed due to a reason, which was the cancellation. So that's important to understand. So far we looked at how to set up replay and how to emit, and those are the basic things to understand, and also how the cancellation works. So you may have code that you're trying to migrate over, which uses broadcast channels, and broadcast channels was the other way to emit items, using channels to emit items to subscribers events. And when you look at both of these different broadcast channels and shared flows, they have different behavior, they have similarities and differences, and there is a strategy that you could use to migrate from one to the other. So here's a simple example of a broadcast channel which emits int values, and it has the ability, and the 10 means that that's how big the cache size is for a broadcast channel in this example. So I could use the channel APIs of sending and closing. However, with a immutable shared flow, it's similar. You have a emit method, but there isn't a concept of closing a shared flow. So the channel, shared flows are, simpler to use. They don't, it's not the same APIs as broadcast channels. And the other thing is the ability to replay. So as you saw earlier, in a shared flow, you could set up a replay count, and that's not the case in a broadcast channel. As you saw earlier in a broadcast channel, you could specify how big the internal capacity of its buffer could be, like 10, size 10 in this example. And with a state flows, what that maps to is the extra buffer capacity is similar concept that you see in a broadcast channel. And the other part is the ability to close. And whenever in Android, you're due to an on destroy lifecycle event, you may close the broadcast channel, but it's not the It's there isn't a similar concept with a state flow. So those are the differences and the similarities of both of those things. And how do you like map one to the other in your code? So you, in this example, you may have some broadcast channel like this. It could be a conflated broadcast channel also. A conflated broadcast channel maps to a state flow, whereas a broadcast channel like this maps to a shared flow. So this maps to like that's capacity that you specify is you could just replace that code with the shared flow with an extra buffer capacity. So wherever you have your send calls, your suspending call send is similar to an emit that you could change to, and try send, which is the non-suspending version, is similar to try emit on the flow. So that's how you map from one to the other broadcast channel and shared flow. So the other thing, last thing that I want to talk about are different flow sharing strategy. So what that means is that with shared flows and state flow, like you may have some upstream flow that you want to convert to either state flow or shared flow. And there are extensions that you could use to do that. So there's a state flow to convert it to that. There's a state in extension, and then for shared flow, there's share in, and I'll share with you how that works. So how do you do this conversion? So when you do this conversion, you have to specify the behavior of how your upstream flow will behave. Like when will it when will it start emitting eagerly, lazily, or while subscribed? And these properties also define how the upstream will like how long it will be active in what cases. So suppose you had a flow and you want to convert it to a shared flow using sharing extension. You specify basically what scope. You have to give it a scope, which is the first argument, because internally we'll use that scope, launch a coroutine, start to read from the upstream flow and push all the data to a shared flow that it creates for you and gives it back to you. The return type of this share in is some shared flow. So you specify the behavior of your upstream flow, what happens as it gets started. So while subscribed, what does that mean? So while subscribed means that it's active as long as the external scope is alive. So the upstream flow is active as long as the external scope is alive. It has not been canceled. So let's look at an example of that. Suppose I were to start collecting from the shared flow. I have a subscriber, and in my code, I take this external scope and I call cancel on it. So it cancels basically the coroutine that's reading from basically the upstream and passing the data to the shared flow. And then that the on-complete will get called on your subscriber. So the upstream flow will basically, you basically stop collecting from it. And the other thing is that it remains active, the upstream, as long as there are collectors. So if I were to add on the upstream the on-completion block, and when will it be called? So over here, I have and it's in a coroutine, I have an instance of its job. And I call cancel on it. And as soon as I do that, the on completion of basically my subscriber gets called, and also the on completion of the upstream gets called. So when that happens, basically my upstream flow stops in that case. So suppose I have two subscribers. I have two coroutines here and two instances of a job. I'll cancel them. In that case, the upstream flow remains active. It doesn't complete. because I still have a subscriber that's active, that's listening to it, to the shared flow. So those are the two properties of while subscribed and what stream flow. So what about eagerly? So as the name suggests, what it does, as soon as you call this method, internally it's creating a coroutine on the external scope and starting to collect from the upstream and emitting to the shared flow that it gives you. And eagerly means that I want you to start that coroutine like before. It doesn't really matter if there are subscribers at all. So suppose on the upstream flow, start method in there, and that should get called whenever this flow starts. I specified what happened, the eager strategy. So at this point in this example, I have created my shared flow using sharing, but I don't have anything listening to it. I don't have any subscribers. So even though I don't have any subscribers, like the onStart method gets called and the upstream flow starts, it starts to read from it. And that's, as the name suggests, that's where eagerly means. But there's another property that it has, is that it never stops. So suppose on the upstream flow, I log out the completion in its completion handler. So if I were to cancel the external scope, which is the scope that it's using to read from the upstream flow, if I were to cancel it, you'll see that in this case, the behavior, it won't complete. It won't, this won't log out. So that's the behavior of eagerly, start producer eagerly or never stop. On the other hand, lazily means that it should only start the upstream flow when the first subscriber appears. And so suppose I specify the lazily strategy and I specify and I log out on start on my upstream flow. So, and I have a subscriber there. So right now you'll see that unlike eagerly, it won't start and log this out. It will only do so when the first subscriber appears. And you'll see this gets logged out in the upstream flow. So that's the behavior of lazy subscription. So it has the same behavior where when you cancel, basically it won't cancel, it won't complete the upstream flow. So these are the three different properties that you could use, the different sharing policies to take some upstream flow and to be able to convert it into like a shared flow. And there's an equivalent of share in. There's an equivalent to that for state flow called state in that behaves like in a similar way, takes in similar arguments. So lastly, you want to talk about some strategies to handle buffer overflows. So you may have you could specify, as I said before, that flow producer that's emitting, generating events really fast, and encourage that are not reading as fast as the producer is creating events. So, but what happens when your buffers gets full? And there are three different ways that you could specify on how to handle that in this scenario. You could either suspend or you could specify some eviction policy to drop oldest or latest. So suspend is the default strategy that shared flow uses. So in this case, the producer code will suspend until the consumer is caught up. So over here, I have, basically in this case, the replay count is 0, but I have an extra buffer capacity of 2. Specify on what happens when it gets the size of 2. It suspends. That's the default strategy that it creates for you, that it uses by default. So this coroutine will suspend. This is my producer emitting, When I get to the third one, it's coroutine suspends. The other one is drop oldest and latest, which will basically drop oldest emission in the cache, drop that one. Most recent one, drop the most recent one and most recent item that was stored in the cache. That's what this will do. So we looked at, how to migrate from, looked at the APIs and properties, how to convert an upstream regular flow to a shared flow, and so post at my website, with mohit.com, that has unit tests. And I want to say thank you for having me in this event, and thank you. It was helpful. So, anyone have any questions? I could take questions. You could reach out. There was a question, and I reached you. You could reach out to me on Twitter. My Twitter handle is Hey It's Mohit, and I could help you out in any way. All right, thank you. Looks like there are no more questions. Thank you for having me.
Thank you, Mohit, for taking time to talk to us today about state flow. Thank you so much. We appreciate your time with us.
Thank you.
All right. Okay. Everyone, we will be commencing a Ask Me Anything session now, and we would love if you would drop